In problem 14.3, we're looking at a few different absolute value functions and what their graphs look like. So we've seen the absolute value of x before. This is kind of our standard version of the absolute value function, and we notice it has its regular vertex at 0, 0 and goes up to the left and up to the right from there. G of x and h of x both make a small change here. They add in the -2 and the +2 inside of the absolute value itself. And we can notice by looking at the graphs that g of x, its vertex is now shifted over. So its vertex is now at 2, 0. Whereas h of x, its vertex is shifted to the left. Its vertex is at -2, 0. So it seems like these functions are, in one way of thinking about it, measuring something slightly differently. It's almost like they are measuring distance from 2 and distance from -2 instead of measuring distance from 0. So let's try to first talk about that down here. What does this 2 do to these graphs? So I'm going to say when it's inside the absolute value, the x -2 shifted the graph to the right. So it moved graph right 2 units. Whereas the absolute value of x +2 moved the graph to the left 2 units. And we're choosing 2 as an example number here. This number could be 5, and it would move the graph more to the right or to the left. For the next 2 examples, the 2 is now in a different spot. The 2 is now outside of the absolute value function. And this has a different effect on our graph. Now I want to try to think about why this might happen. In this case, when I plug a number in to my absolute value, so some number goes in here, what happens is it spits out a positive version of that number. So let's say I put in -3. It spits out +3. But then the next thing it does is subtracts 2. So what this -2 does out here is it takes my whole graph and moves it downwards by 2 units. Whereas this +2 takes my whole graph and moves it upward by 2 units. So we can write that down out here, or write that down here. The absolute value of x -2 goes down 2 units. And the absolute value of x +2 goes up 2 units. The next part asks us to think about a possible explanation for this. Well, we already started to talk about why this happens to these 2 graphs here. Right? On j of x and k of x, you do the absolute value first, which is going to give you that V shape, but then the last thing you do is subtract 2, which subtracting 2 makes all y values go down by 2. And over here, same thing. This makes them all go up. All your y values go up by 2. It's a little different up here, although we also started talking about this one already as far as like distance from 2. But you could also make other arguments here if you wanted to. So let me just throw one out there. To find the vertex, we have to find a number to plug in that will make the inside of this 0. If I plug in 2, I get out 0. That's why my vertex is there at 2, 0. Numbers that are bigger than 2 are going to be giving me a positive output again, and numbers that are smaller than 2 would normally give me a negative, but because there's the absolute value here, they become positive. So that's all these numbers on this side of the graph. And then the h of x function just does the exact opposite. Right? -2 is what would give me 0 as an output there. There are other ways to think about this and justify why the graphs move these ways, but that's just a couple of ideas.